Engineers and by Oxford. On behalf of President of Children's Education Society and Chairman of Oxford Educational Institutions, Management, Principal, Staff and students of the Oxford College of Engineering, I extend a very warm and hearty welcome to our resource person, Ms. Archa S. Nair, Application Scientist, Zastra Innovations. Now, I take it a great pleasure in introducing our resource person, Ms. Archa S. Nair. Ms. Archa S. Nair is an application scientist at Zastra Innovations, where she primarily focuses on providing scientific software support to research community across India for drug discovery software like CSAR, StarDrop, Infancy, and Cosmotherm. She is a mentor to graduate interns and does analysis of research data and benchmarking pilot projects, which involve target identification, virtual screening, scaffold hopping, lead identification, and chemical space exploration. Ms. Archa is a bioinformatics graduate from Amrita University. She has expertise in areas of molecular docking, computer-aided drug design, and next-generation sequencing. In her current role at Zastra, she supports scientists in developing lead compounds for challenging targets as drug candidates with balanced properties using multi-parameter optimization approaches. It is indeed a great pleasure to have you here today, ma'am. I kindly request Ms. Archa to take over the session.
And they give this internship opportunities on this also. You just go through and listen carefully. Okay. So if your project works or any related to that, you come and contact me. We will contact them for further.
No.
So I just wanted to check whether any of you have any idea what docking is and computer-aided drug discovery, what it is. Okay. So you have an idea. So first what I'll do is I'll go through the basics one. What actually we will be doing in computer-aided drug discovery, and then following that I'll show you a demonstration of our software. So first, I wanted to introduce you to computer-aided drug discovery. Basically, before that, myself Archa. Okay, you might have got an idea, and I'm having a bioinformatics background. And what what brought me into this field is that it is like multidisciplinary. We always are a bit confused where we should go, like IT field or bio field. So I like the bio field. Then I was in a kind of dilemma. So that's why I chose this bioinformatics field. That means it's a mixture of both. So about us, Shasta. So we have different software for ADME, human toxicity profiling, computational medicine and chemistry, material science, API processes, cleaning, docking with water, metallurgy, CAD, chemical informatics, ELM, etc. Then, before going into the software, first I want you to know what all are the processes that we have to undergo before a drug, a medicine reaches our hand. It might be a virus, so the virus might be having some compounds in its body. So where is it going and attaching in our body? So that is the first thing we have to identify. That is target identification. So this target identification means this target can be a protein inside our body. Then after identifying the target, imagine we have a PDB structure or we did a homology modeling and we made the structure of the protein. Then what we have to do is, next step is lead identification. Lead identification is like after finding the protein, now we want to find we know which compound is inhibiting that protein. So we want to do something about it. We want to stop this action. So then we have to find a complementary lead ligand gas. So ligand identification is the or lead identification is the second step, and this basically we'll be having what we'll be doing is we'll be screening in case if I want to make some drug out of phytochemical. Apart from this, we have other tools like this document. Yeah. After the document, you get the result table showing you some parameters like binding, like bond angle, bond width, and some RMSP values also. Yes. So in this, is there the option? Yeah, it is there. So it is like we'll get a table after performing the docking. We'll get a table. So what all will be there is there will be having a high score like I mentioned earlier. So it's like range. So if it comes towards the left means that is good. Then we'll get torsion angle whether it is good or bad. Then we'll get LLE, we'll get ADME properties, molecular weight, this log S, log D, everything will be there in the table. It's just that we have to select whatever we want and add it into the table. What if the table that all the values will be the negative thing? Negative value. Yeah, it can happen. Like what to say? High score also. Then if I take the example of high score, the lowest negative will be the like best value. So it's like that. So sometimes the range will also be different. Like if I am taking 0 to 5, sometimes in the case of solubility, if I am taking the one that is greater than 2 will be having a greater attraction towards fat. Then the other will be having towards water. So like if you check if fat is here and if you are considering this value and focusing on fat, that means negative is not good for fat solubility. But if you take the case of water, that means negative is a good value. So it is based on the parameters we are considering. Now, if I am explaining each mode, protein mode is where we will be loading our protein. Like I mentioned, then we just have to give the PDB ID. So it's connected to the PDB database. It will directly download and it will be given to us in a prepared manner. All the protonations or water molecules that are to be removed are taken care of. Then protein editor mode is where we'll be editing our protein and mutations, introducing mutations. If we don't want any side chain, we can delete it. So all the changing amino acid into one another. So all this can be done in protein editor. And also there is one algorithm which helps us to find all the proteins that are having a similar binding site to that of our protein. Like again taking the example of coronavirus. So how we did that was we got the structure of the virus. We compared it to how we got the structure is we compared it to the parents of the or the same family. That's how we got the structure. So here also, if we get an idea of the binding site, we will be able to find all the other proteins that are having a similar binding site. So we will be able to find the relatives. Now binding site mode, it predicts the binding site automatically for you based on the ligand. If you want to do any sort of like manipulation, just type the PDB code or load the homology model, that whatever you have done, or if you have downloaded the protein also you can load it. Then here itself you can see this one. 1STP is my protein and biotic was my co-host. Yeah, we can directly download. Just put the PDB code here and then it will be downloaded. Or you can download and load also. Anything is possible. No. From here itself you can download. So then this is the focus step that we are having. You can see the estimated affinity. See how good it is. So we know this is a reference that we can use. Then if you see here
But modifying the compound is limited to the ligand-based components. You
Yeah,
cannot
ligands.
modify the compound based on temperature, pH, etc., etc., etc.
No,
Those
that-
cannot be very purely a compound can be used.
So from here, we'll be able to understand that this structure is having an issue. This suggested structure is having an issue with the protein. So it will be having an intramolecular clash, also a clash with the binding site. So the software itself is telling this is not a good option for you to continue your work. So focus on something else. Then linking and merging, like I mentioned, if you add two molecules, you can link or merge this together. Then yeah, docking. Space docking is something that is going to be added to that.
So the docking is automatically based. Automatically happens. So what is the difference between docking that occurs here and docking that is done using other software things like this?
Yeah, this what it does is it makes our job easier. Like all the things are running in the back end. All we have to do is select the binding or set the binding site. And in case if you are having almost million compounds, so all the million compounds are docked simultaneously to the protein to give us a result. So it's like we are getting like saved from a lot of time. So we can save a lot of time. So that is here I have already done doc, performed doc. So that is why you are showing, you are getting the result. But if I am showing from here itself, you will be happy. So from here, when you load your ligands into the table, you will get an option like standard docking, you want to go for standard, template, or covalent docking. So you can select which docking you want. So if you want to go with covalent docking,
Size. We wish we would have some more time to interact with you, but unfortunately, it was not possible. But we, from the Department of Biotechnology, College of Engineering, we had Charles Nayak, Miss Aisha Nayak, of Strategies, for spending valuable time here. Please give her a round of applause. If you have any doubts, then definitely contact me. You have your some time.
yeah, sure. We are like always happy to help people who are interested in research. So feel free to email me at the support at